In this lesson, we're going to tackle a couple of sort of less common methods of integration. The first one is going to be using long division. So a lot of your experience in Calc 2, if you go out and take Calc in college, will be learning how to solve integrals by various methods, right? So derivatives tend to follow the same rules. Integrals tend to be a little bit more complicated. So depending on the function, we end up learning a lot of different methods to tackle the integral. A lot of the things you learned in Algebra 2 and in pre-calc actually are in those curricula because they're preparations for these types of integrals. Long division is a great example of that. So polynomial long division, don't run into that a whole lot in real life, but it's useful for solving this type of integral where I have this rational function here. So there's no quotient rule for integration, but I can rewrite this as a power rule function. So what I'll do is I'm going to divide these out. And I like to use just plain old long division. The delta math examples use synthetic division, which you may or may not have seen before. It's the same steps, the notation's a little different. So to divide these, just as a reminder, I'm looking for what times x minus 3 would give me a 2x squared. And the answer to that is a 2x. And then I'm doing 2x times x is 2x squared. 2x times negative 3 is negative 6x. And then I'm subtracting. So that means I distribute my negative. If I've done it correctly, my first term cancels out. And then I get negative 7x, negative 13x plus 6x. And I bring down my 22. Okay. Make sure you follow that. This should be a review, but that's how the steps work. It's the same as long dividing numbers, right? So if I had, 672, and I'm dividing it by 5, I'd say 5 goes into 6 one time. I would have 1 left over, and I'd bring down my 7, right? And then I'd say 5 goes into 17 3 times, and so on and so forth. I'm doing the same thing just with this polynomial. Let's see what I got here. Negative 7 times x gives me negative 7x. And then I get 21. I subtract these. And then my first terms cancel, and I have 1 left over. Now, we're going to write this as a remainder. Okay? So the way to write my solution with a remainder is this division problem. So my original integral becomes still the integral from 4 to 6 of my result. So 2x minus 7 plus my remainder over what I'm dividing by. So 1 over x minus 3. Okay, so that's a way of noting that I have a remainder, is writing it as sort of a little rational fraction here. Okay. So these two integrals, my original integral and this integral, are equivalent. Once I've done that division, now I just integrate. So first two are power rule, right? So I get x squared. It even has a 2 out in front for us. That's nice. Minus 7x. And then this, well, this is a natural log integral, right? So I could do a little u substitution here. I could say for just this integral, I could say let u equal x minus 3, and then I could and then du would be just 1 dx, du would be dx, right? And then I have 1 over u du. And then if I go my integrals reference, or my derivatives reference rather, that is my natural log derivatives rule. So the result of that, and this is always the case if you have a plain old x plus or minus something, is just ln natural log of x minus 3. And notice it's a definite integral, so we're not going to plus c. We're going to say from 4 to 6. And then we're going to evaluate. So 6 squared minus 7 times 6 plus the natural log of 6 minus 3 of 3 minus, plugging in 4 now, 4 squared minus 7 times 4 plus the natural log of 4 minus 3. Okay, let's simplify that sum. So 36, I was getting ahead of myself there. 42. Natural log of 3 we're just going to leave. So on Delta Math it asks for your answers with natural logs in it rather than a decimal. So this will get us like some irrational decimal. We're not going to type that into our calculator. I'm going to distribute my negative and combine some of this. So 4 squared is 16. Get a positive 28. And then minus the natural log of 1. Now we're just combining like terms. Combine all of my plain old numbers. I get a positive 6. And then plus the natural log of 3 minus the natural log of 1. Now in Delta Math it asks you to have just one single logarithm. So that means I use this rule. So the natural log of x over y is the same as the natural log of x minus the natural log of y. Right, so I'm going to use my logarithms rules to combine these. So this ends up being 6 plus the natural log of 3 over 1, which of course is just 3. So the usefulness, the reason these rules were useful and the reason you learn these in pre-calc is because it allows us to save, like not have big ugly decimals in our work and just save the answer in a nice easy to write down way. Okay. So again, there's two kind of new-ish things here, but they're actually old things. So when we get a rational function, we're going to divide using our long division steps. Your remainder is going to often end up being a natural log derivative. So that's how we get a lot of logarithms in these. Other than that, it's the same as what we've already been doing. So I'll zoom out so you can see the whole example. They are time consuming, but not necessarily super hard. Here are the steps.